visualize the factored form of a polynomial, and we're going to write a polynomial function from its zeros. We might not get to that one. That might have to wait a little bit. So if p of x is a polynomial function, because this is function notation, remember. It doesn't have to be f of x, p of x, q of x, h of x, all those things are all fine. The solutions of the related polynomial equation p of x equals 0 are just called zeros of the function. Solutions are zeros. Finding those zeros, of course, helps us to graph the function. If we know where we're supposed to get a 0, well, that's either on the x-axis or the y-axis. We can put some points down, so that's really helpful. So finding the zeros of a polynomial function helps us to factor the polynomial. So at this point, if you're saying, oh gosh, when I looked at that stuff over there, I thought, factor? Oh, I'm always been really bad at that. Well, we can kind of cure that by doing an educated cheat, by finding the zeros on the calculator and working backwards. We can graph the function, which is what we need to do. And we can solve the related polynomial equation. So all of those things, if we can find the zeros. Because what we have to do is figure out, how do you know what this is going to look like without putting it in the calculator? Well, we already get a pretty good idea about this thing. It says x cubed minus 2x squared.
It's gone. Go. Okay.
We have x cubed. We already know it's going to look like this. But I see these other terms behind it, and I say to myself, there's probably going to be some lumpy bump stuff in the middle there where there's some turning points. But at least I know for certain it's going to do this and it's going to do that, because that's essentially needed. But what I have to do is figure out what are some other things that I can find out about this graph. And it's going to come from factoring this. So we go to our good old factoring list in our head. Is there a greatest common monomial factor that we can pull out of all of this? Yeah, let's take it out. Looks like so. Then we check for perfect squares. No, negative 50 is not a perfect square. Remember, the front and the back have to be perfect squares. So that's not going to work. But good old-fashioned factoring might. Two numbers are multiplied to negative 15. Negative 2, negative 5, and positive 3. There it is. Well, now how does that help me with this graph? Because if we find the zeros, which I know this doesn't ask us to do, technically we would be done right here. The zeros are going to be at 0, 0, 5, 0, and negative 3, 0. So now I know a little bit more about the middle of that graph. Remember, before all I knew was there were probably going to be some turning points there because there's other x's behind it. But now I know specific spots where it's going to cross. So all of this is about being able to look at any function and figure out, hey, it kind of looks like this, without having to do any of the graphing. So let's see if we can do this one. And I'm going to use the duckies today. So what I want you to do is go ahead and start factoring this, and then I'll ask somebody what the first step is, what the second step is, and all of that good stuff by pulling your ducky out of the bag. Josh, you're the lucky duck. First one. What are you pulling on? Oh, you're too far ahead. We just want first step. dx. Yep. Step. Our timer gets way in the back there. X minus 4 and x plus 3. So again, I'm looking at this overall and thinking to myself, x cubed will look like this, but probably has some turning points because there's other x's behind it. And I would say, oh, well, it's going to cross at 0, 0, 4, 0, and negative 3, 0. Again, for this problem, they just wanted us to stop right there and say, hey, here's what this looks like in factored form. But this is where we're going with it. You know, we're going to up that objective, do a little bit more than what we've known how to do in the past. So now, this big box needs a whole lot of highlight. So if you don't have a highlighter, grab a highlighter out of that bag. Because this tells us all the uses that we have for all of this good stuff. The following are equivalent statements. That means they all basically say the same thing. They use different words because we're using the math for different stuff. So it says x minus b is a linear factor of the polynomial p of x. Well, that's what we were just doing. We were factoring these things so we could figure out where the zeros are. Once you have those factors, it's really easy because b is a 0 of that polynomial function. Yes. Then another name for solutions is actually roots. Now that I know seems a little bit weird. I'll show you why in a second. And finally, that means it is the x-intercept of the graph. The x-intercept of the graph. Now why on earth would they call them roots? Because if I ask you to solve that, some of you would factor it and do x plus 4 and x minus 4 and find the zeros. But some of you would say, I'm going to add 16 both sides, and then I'm going to take the square root. So x equals plus or minus 4. So that's why they're not just called solutions. They could also be called roots, using it that way. So all of these things are found the exact same way. We factor, and we find the zeros. That's why they're equivalent. They're just used for different things. If you want to graph it, you go all the way down to the x-intercepts. If you just wanted to know where they are, you'd stop right here at the zeros, the second step. So it's all about what do you want to do with it. This one, we're going to put it all together. Problem 2 says finding the zeros of a polynomial function. And this is already factored for us. Almost wish they wouldn't have done that. I think we could have done okay with factoring. So what we have to do is find the zeros. What will make that 0 in the parentheses? Negative 2. What will make this 0? 1. And what will make that 0? 3. Now what's important is that we realize by saying that, we're saying if you put negative 2 into this function, you're going to get 0, which is a point on the graph. If you put 1 in, you're going to get 0. There's another point on the graph. If you put a 3 in, you're going to get 0. So there's 3 points. It says graph the function. I want to do as much as possible without that graphing calculator. So I look at what would the degree of this thing be? Well, if we multiplied all this together, x times x times x would make this x to the 3rd. There are no negatives in front of any of the x's. So that means it would look like this for end behavior. Now I'm going to use that because I know this is supposed to cross the x-axis at negative 2, 0, 1, 0, and 3, 0. So think about what I know from the degree And I know this is supposed to go down as you go to the left forever. So I go to this left 0 and I say, I know that's going to happen. It absolutely is going to happen because x times x times x is x to the third. And I also know that's going to happen right there. Now the next part I'm going to make dashed because I'm not real sure about exactly how this is going to go, but I know it has to do something like that and something like that to make this happen. Now, I have pre-calculus students for 3 sections of it. We're in pre-calculus. We still cannot figure out where the maximums and the minimums are without a calculator. You have to have calculators to do that. So that's why we have graphing calculators, is to actually find where's that highest point over here and where's this lowest point. So what we have to do is punch that in, parentheses and all. I'll give you a second to do that. It's the very first one that I have up here. And we're going to figure out where our hills and valleys are at. Everybody have it in? Okay, your parentheses are right here, so use those. Just the top one. That's all we want right now. And if we want a negative 10 to 10 window, what do we hit, everybody? Zoom 6. So once you have that top line in there, hit zoom and 6 because that's a negative 10 to 10 window. Oh, look at that. This is going down. This is going up. It's crossing right at the points that we said it was going to cross. That's that one piece of information we need. We need to know what the tip top of that hill is. Now the reason I'm putting those little marks there is because we're going to use the calculator to get that. And we're going to tell that calculator that is the left side of the hill and this is the right side of the hill. And then we're going to go and do the valley. And we're going to tell the calculator this is the left side of the valley and this is the right side of the valley. And it's going to tell us exactly where the tip top of that hill is and the very lowest point in that valley is. And that is all under second trace. You see where it says maximum? That's where we get the top of the hill, is the maximum. So we're going to hit number 4. And Blinky's going to show up. And Blinky is right here. Well, he's asking for the left of the hill. That's not the left of the hill, it's the right. Come on, Blinky, you know better than that. So with our left arrow, we're going to move Blinky over to the left side of the hill. Now, you don't have to go very far over the top of the hill. You just have to make sure that it starts to go down. And then you can press enter. And then Blinky's next question is, hey, is this the right side of the hill? No, Blinky, you were over there before. So let's move Blinky over to the right. Again, you don't have to go very far down the hill. Just a little bit. You press enter. And again, Blinky's playful and says, do you want to take yes? No, Blinky, I don't want to take yes. I'll just hit enter. And Blinky tells us where the top of that hill is. So we're going to write down, we have a max at negative about 0.8. That'll probably be good enough for graphing. Negative 0.8, 8.2. Now that helps me know where I should put the top of this turning point. So negative 0.8, 1, 2, 3, 4, 5, 6, 7, 8, and a little more. So I was way off with my dashed guess there. Up and back around because it has to hit at 1, 0. Well, now this was the other one I wasn't very sure about, and that's the bottom of that valley. That's a minimum, and that was also something that Blinky could give us. So let's go back and let Blinky give us that. Second trace. Now we can see number 3 is the minimum. And again, Blinky's say, hey, is this the left of the valley? Oh, goodness. This might take a little while on my calculator. Blinky, you are totally lost. That's not the valley, that's the hill. So, got to start hitting right arrow until I can get Blinky down here on the left side of the valley. That's a pretty good spot. And hit enter. And then we'll get Blinky to the right side of the valley. Anywhere over there is good. Hit enter. And again, we're just going to hit enter through guess and let Blinky find it for us. Enter. So Blinky says at about 2.1, we're at negative 4.1. So that's where our lowest point for this graph is supposed to be. So, oh no, it shouldn't be negative 2.1. What was it? Positive 2.1, of course. Maybe I just pulled the wrong number down. There we go. Oh, I can't hang on to mark. So 2.1 and 1, 2, 3, 4, and a little bit more. So like I said, I know it's disappointing to know that you have to learn calculus to be able to find that using algebra. But what it does mean in here is you're going to be able to use your graphic calculator. You know, and you can find your max and your min by letting Blinky do all the hard work. So most of this you really were able to do without a graphic calculator. To look at it and say x, x, and x, oh that's x cubed. Zeros are negative 2, 0, 1, 0, and 3, 0. That's really the hard work. And Blinky just takes over finding that max and min for us. So let's try this one, but I'm going to ask questions with the duckies. So, wherever there's an x, there's a solution. There's a little x sitting out in front of there. I need somebody to tell me when that's going to be 0. And Lana, that ends up being you. What could you put in for x that'll make it 0? Exactly. Yeah. You know, sometimes it seems kind of weird to talk through those. So 0, 0 will be a 0. Then we have the parenthesis x minus 3. I need to know what number will give us a 0 there. It would be 3, 0. And then I'll go with blue for the x plus 5. So we need to know what number is going to give us a 0 there. And that will be Brandon. It is negative 5, 0. So let's get those points on here. 1, 2, 3, 4, 5. 0, 0. And 1, 2, 3, 0. My next question is, what degree is this going to be? So we know what the NBK here is. I'm taking my glasses off. Abby, what degree is this thing going to be? Going to be 3, going to be a cube. As she said, we've got x times x times x. So cubic. And that tells me, since there's no negatives in front of it, down and up is what I need for this one as well. So this is going to go down from here, and this is going to go up from here. And again, I just take a guess at somewhere up there, then it's going to come down somewhere over here, but I'm going to use Blinky to find that. I need to know where it is, so I'm going to have to punch it in. So take a minute here, punch in x, parentheses, x minus 3, parentheses, x plus 5. And then the next duckies will be, I'll ask somebody to tell me what they got for maximum. And what they got for minimum. All right, we've got an issue with this one. Can you see the top of the hill? Can you see the bottom of the valley? So we have to change our window because negative 10 to 10 is not going to do it. In fact, boy, 20 might not even be high enough for that one. That one looks like it's pretty high.
40.
We can try 40. Let's try negative 40 to 40 for the y's. Not for the x's. The x's are fine. You can see everything on the x-axis. It's just here. We need to maybe try negative 40 to 40. And then hit graph. Don't hit zoom 6 again. Go back to negative 10. Good with me, Jess. All right, so now what I need you to do is second trace max. Finding the top of the hill, write it down. 1 decimal place is good enough. And then find min, write it down. After you're done, you got the max for me because your ducky's here. Negative 1.6. What is it? It's higher than that. The max higher than that? Yeah, I have 36. Negative 336. Try that one again. See if you can get the negative 336. Yeah, that's what I had earlier. And then the minimum, and you might not be ready yet, so let me know if you're not. This one whole guy needs a minimum. Are you ready with the min? Not yet. Oh! Let me do it up here so we can see if you're getting the same thing. All right, so second trace, number 3, the min. Let me split these in a little bit better position this time. Left side of the valley. So 1.7, negative 14.8. Now that tells me I can't go by ones on the y-axis. Remember we had to change the window? And we went to 40, but yeah, it looks like that's what we're going to have to do anyway to get this 36 on here. Each of these spaces we've got 10 by 10, so we probably should go by 4s. Not the x's, just the y's. So at negative 3, 1, 2, 3, we can go, well, almost all the way up. We've got 36 there. So we'll go up 9. 9 times 4 would give us that 36. And then 1.7, so not quite 2, 4, 8, 12, and a little more. And we can finish off that graph. So there's just the max and the min that we have to ask the calculator for. And the rest of this we can put together. We know what we're doing. So let's look at a couple more where we're talking about factoring. And it says the expression x minus a is a factor of the polynomial if and only if the value of a is a 0. That makes perfect sense. You know, from what we saw from the graph, you have to get 0 in order for it to cross. So this says if we had to write ourselves a cubic polynomial function in standard form, how would we make that happen? Well, they're giving me these. There's 3 zeros. That should give me a cubic. So I have to think backwards. And it does say polynomial function, so we can't just call it y. We have to call it f(x) because it's in the direction we said that. And I think, okay, what would have to be in the parentheses for negative 2 to be a 0? Well, that'd have to be x plus 2. Because then I'd put a negative 2 in there, and that would give me 0. So if x plus 2 gets me negative 2, what should I put up there for 2? X minus 2. And what should I put up there for 3? X minus 3. And then this just becomes FOIL. You know, because we're going to do FOIL. I usually just pick 2 that would be nice and easy to do FOIL with. These 2 are going to be super easy to do FOIL with because it's a sum of difference pattern. So f of x equals x squared minus 4. First times first, outside times outside, and inside times inside cancel out. And now we're just going to do FOIL one more time to see what this polynomial would look like. So that will give us, that's not an x, x to the third. Because in yesterday's homework, remember you had to multiply the same base, and when you do that, you add the exponents. And then we'll have outside times outside is negative 3x squared, inside times inside is minus 4x, and last times last is plus 12. Now, if we want to check that, we can't check the whole thing, but we could put this in our calculator and make sure it crosses at negative 2, 2, and 3. And I think I put this one in earlier, so don't bother taking the time to punch it into yours. I'll just activate it here. But we want to make sure that it's going to cross where we said it's supposed to cross. So it should graph now in black. And it better cross at the zeros that we had, which were negative 2, 2, and 3. It does. Now the one thing we can't tell is it going high enough for the top? Is it going low enough for the valley? That we can't do without knowing more information. But at least we know it matched our zeros, so we know we did something right. So now I'm going to have you guys help me out a little bit more with this one. What is a quartic? Oh my, that's going to take a little more work. Quartic polynomial function. I'm going to call this one g of x just so it has a different name than the last one. And it says the first 0 is negative 2. So what I need is, what's that going to look like in the parentheses? Samantha, what's negative 2 going to look like one step backwards? X plus 2. Also, Samantha just took 2 of those off the board. We've got another negative 2 up there. Then I need to know the 2. What should that look like in parentheses? I've got Caitlin. X minus 2. And then I need to know what the 3 is going to look like in parentheses from Gavin. X minus 3. Now we get to pick which of these we multiply together first. I don't know about you, but that last one I really liked, this pattern right here, so that I could eliminate some variables there. So if I do that one first, that would give me x squared minus 4, but I would still have my little x plus 2 and my x minus 3 to multiply together. So at this point, because none of these are going to be nicer than any other ones if we multiply them together, I would probably just multiply these back two together first. So let that x squared minus 4 hang in there for a second. Minus 3x plus 2x will give us minus 1x minus 6. It's been a while since we had to do this, but do you remember how to multiply x squared minus 4 times x squared minus x minus 6? Anybody remember? I see people doing this. Yes, we're going to take x squared times everything over here. Then we're going to take negative 4 times everything over there and pull it together. So x squared times x squared is x to the 4th. X squared times negative x is negative x to the 3rd. X squared times negative 6 is negative 6x. Negative 4 times x squared is negative 4x squared. Negative 4 times negative x is plus 4x. Negative 4 times negative 6 is plus 24. And now all we do is combine like terms. So g of x equals x to the 4th minus x to the 3rd. We have a negative 4x squared. And it turns out there's only two of these we can put together. It's negative 6x plus 4x. Negative 2x plus 24. And again, we could graph it. We want to make sure it actually isn't going to cross at negative 2 because negative 2 showed up twice up there. It's going to bounce off at negative 2. But there it is. And I should check and see. I would look for time whether or not we have to graph this. So graph both functions. How do the graphs differ and how are they similar? Let's go on to something else for just a second. If we have time on Monday, we'll come back to this, but this is kind of a waste of time because you can put it in your graph calculator. And this one has us writing some more polynomial functions, but writing them when things are a little bit more difficult. So this one says we want to write a polynomial function in standard form, and it has zeros at 3i and the square root of 2. Well, here's the bad news. These things don't come alone. Imaginaries always come in pairs. So if positive 3i works, then negative 3i also has to. And radicals don't come alone. Think about the quadratic formula. There's always a plus and minus in front of it. So we actually have 4 zeros for this one. So when I write my polynomial, I guess I'll call this one h of x, I'm going to need x minus 3i, x plus 3i, x minus the square root of 2, and x plus the square root of 2, which looks awful. How are we supposed to multiply that together? But it turns out, if you multiply the two i's together, you get something nice. And if you multiply the two radicals together, you get something nice. So, just group these with their like binomials, and then do the FOIL. And if we do that, we get first times first is x squared. Outside times outside and inside times inside cancel out because one's a plus and one's a minus. And last times last will be minus 9i squared. What's I squared, everybody? Negative 1. So this will actually become x squared plus 9. Right there. I guess. Then in the back, x times x is x squared. Outside times outside and inside times inside. Going to cancel right out. What's the square root of 2 times the square root of 2? what's the square root of 4? 2. And now this we can just do with FOIL. And there's no more nasty radicals, and there's no more i's in there anywhere. So first times first, x to the 4th. Outside times outside is minus 2x squared. Inside times inside is plus 9x squared. Last times last is minus 18. So h of x equals x to the 4th plus 7x squared minus 18. Now, this one we can't really check by graphing. Here's why. Imaginaries don't show up on the real numbers that are in our graphing calculator. So we wouldn't be able to see those. We would be able to see this. It's going to cross at 1.414 blah, 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 and negative 1.414 blah, blah, blah. That we could check, but we can't check those imaginaries. So this is a good place for us to stop because we can start with this one and hopefully everybody will remember what we're talking about today. Not everybody's a little duck call, but that's all right. And you'll get a little practice.
Holy
That. Just that one. This is a 3-day section. You know, there's a lot here. And we are going to have to use those graphing calculators to help us out whenever we're graphing. But we want to do as much as possible by hand. So we have made a dent into analyze the factored form of a polynomial and write a polynomial function from its zeros. But we're not done yet, you know. This is definitely going to be 3 days worth of good stuff here.